Hi, today we're talking about bivariate regression analysis. And for this problem we're going to use the data, and what we want to know is how much of y x can predict. That is, y over here is the dependent variable and x is the independent. And I put a little graph in here. You've got your x-axis and you have your y-axis. And so I plotted the points where x and y intersect on the graph. So if you have an x of 11, follow that up till it intersects with 8 on the y-axis, and I plotted all those points just to show you what it would look like on the graph. So anyways, we need to find the slope, and the slope is covariance divided by variance. And so this is the equation for covariance, and this is the equation for variance. This up here is the equation for the y-intercept, but we're going to worry about finding the slope first. So the first thing that you really have to do is, when we're looking for the slope, is you need to find this x bar and y bar, and that's just the average of the x values. So I took these x values, I added them up, and I divided by 5 to find the average. I did the same with the y. I took the y values, added them up, divided by 5 to find the y average. So, and that's just called y bar, x bar. Alright, so now we can work with this. So you have your x values and you write them down. So you've got 11, 10, 9, 6, 8. And you put them in here, 11, 10, 9, 6, 8. And you minus it by x bar, which we determined to be 8.8. So you minus that 8.8, and then you get this value, 2.2. Okay. 10 minus 8.8 is a 1.2, so on and so forth. We did the same thing with y. We start with our y values, which are 8, 7, 4, 9, 10, and we put them in here, 8, 7, 4, 9, 10. And we subtract the average y values, or y bar, 7.6. So 8 minus 7.6 equals 0.4, and so on and so forth when we do that. Alright, so now you've got these parentheses and you've got your values, but what you need to do is you need to multiply them. And so what we do is we take this 2.2 and we multiply it by 0.4. So you've got that 2.2 times a 0.4, and that's going to leave us with a 0.88. And we do that for this one, this one, this one, and this one. You just keep going. So 1.2 times a negative 0.6 is going to leave us with a negative 0.72. A 0.2 times a negative 3.6 is going to leave us with a negative 0.72 as well. Negative 2.8 times this 1.4 is going to give us negative 3.92, and a negative 0.8 times 2.4 is going to leave us with a negative 1.92. So you've got this symbol right here, sigma, which means to sum. So you add these up, and the sum is a negative 6.4. So we know that this top part up here is going to be a negative 6.4. Okay, and then we're going to divide that by the number of items we have, minus 1. So 5 minus 1 is 4. So when we do that, we get the covariance to be a negative 1.6. Now we need to find the variance, and so for this this is what you call the sum of squares. And so what you do is you take x minus x bar and then you square it. Well, we already have the x minus x bar values. They're right here in this column, so we just need to square those. And so what we do is we say 2.2 squared plus 1.2 squared plus 0.2 squared plus negative 2.8 squared plus a negative 0.8 squared. Alright? Now that is going to give us 14.8. 14.8. So we got the top part, 14.8 over n minus 1, which is 4. And that's going to give us 3.7. Now we need to find the slope. So B is going to equal the covariance, which we determined to be at negative 1.6 over the variance, which we determined to be 3.7. That is going to give us a negative 0.432. So the slope is a negative 0.432. And how you interpret this is for every one place of x, y is going to decrease by 0.432. So when you see that negative sign, you know that the trend is that the y value is going to go down. And for every one position of x, this y value is going to go down by 0.432. Now if this is a positive, you have a positive uptrend. So for every position of x, your y value would move up by 0.432 spaces. Alright, so now we find the slope. How do we find the y-intercept? Well, we've got this equation up here. A equals y bar minus b times x bar. So we say A equals y bar, and y bar is what we had, 7.6. Alright, so we got 7.6 minus the slope, which is right here, that's the slope, minus a negative 0.432 times x bar, and x bar is 8.8. So 8.8, and that is going to give us 11.4016. So that is your y-intercept. That means that the line is going to pass through this y-axis at 11.4016. And so when you plot this, you go up here, you got 10, 11, and so 11.4 would be somewhere right around in here. Now if you wanted to find the line, you would just have to input the value. So you know that, because we know the slope, we know that for every position of x, it is going to decrease by a negative, it's going to decrease by 0.432. So what we're going to do is we're going to say it moves 10 places over, which means it would decrease by 4.32. So let's say we do this and we're saying the y-intercept is 11.4016 minus x places, which is 10 places, times 0.432. So we're going to say minus 4.32. So we take 11.4016 minus 4.32, and that's going to give us 7.0816. 7.0816, and like I said, I'm only doing this to get a second point so I can draw a straight line and show you what the the regression line looks like. So we went over 10 places and we go up 7. So 1, 2, 3, 4, 5, 6, 7. So it's going to be right here. And then we just draw a straight line through the points, and that is our regression line. And the area, you could determine that the areas are the same using calculus, but if you visually look at it, if you were to look at this as a 3D object, you would see that it basically passes straight through the middle, and that each side has exactly 50%. And that is how you find the y-intercept, the regression line, and slope. In the next video, we're going to be talking about how to calculate y hat, as well as the standard error of estimate.